Welcome to even and odd functions graphically. So take a minute and look at these three graphs. What do you notice? You might have noticed that they're all symmetrical over the y-axis. Essentially what that means is that it looks like it could be folded in half down the y-axis, right? So the left looks like the right. For example, if you have the coordinate, let's say this is 1, 4. When you go to the opposite value, instead of looking at x equals 1, if you look at x equals -1, it's going to have the same height. So -1, 4, right? If you have -1, 1 on the left, when you reflect it over the y-axis, you're going to have the same height, so 1, +1 on the right. Same thing with the last one. If you know you have a coordinate of 1, 1, if you know that function is symmetrical over the y-axis, this is going to go to -1, 0. So our x values are flipping, but our y values, the heights, are staying the same. Now, these functions that have these properties are specifically known as even functions because they have symmetry over the y-axis. That means when you have a coordinate, x, y, you know that you're also going to have the coordinate -x, y. So if I told you an even function had 2, 3, I should know that another point on that equation is -2, 3. Here's a graph of an even function. What we say is, remember f of x is also your output, your y value? Well, the output of f of x is going to be the same when you put in a -x. This is just saying that your y values, the outputs, are the same whether you input a positive or a negative. Now take a minute to look at these graphs, and it might take you a little longer to figure out what they have in common. You might have noticed that these graphs all have symmetry through the origin. What that means is, let's look at the middle graph. If you have something on the top right, symmetry through the origin would mean it goes to the bottom left. So if I had the coordinate 2, 3, the top right, I'm now going to go to the bottom left. So this coordinate, if I was on the right, to make it go to the left, I take a -2. And if I was on the top to go to the bottom, I now have a -3. If I had a coordinate here, -3, 3, well, I'm on the left. So symmetry through the origin would mean I'm now on the right at +3, and I'm on the bottom now. So that +3 up top goes to a -3 on the bottom. If you're still having trouble seeing this, a very easy way to tell if something has symmetry through the origin is if they look the same when turned upside down. So if you look at these three graphs upside down, they will look the exact same way. For example, this one. When I turn it upside down, we see the same image, right? And when you overlap it, it falls in the exact same spot on the XY axis. So really quick and easy, even functions can be folded in half, symmetry over the y. These are called odd functions. You can turn them upside down when they have symmetry over the origin. That means if you have a coordinate x comma y, that goes to negative x comma negative y. Something on the top right goes to the bottom left. Okay. If we look at a different graph of this, f of x is not going to be equal to f of negative x. The reason for that is your y values are the opposite. So let's start with this. F of negative x, when you input a negative x value, it's similar to plugging in a positive x. The only difference is that instead of being down here, we're now up here. So the y values are opposites. So the y value down below is negative of the y value up top. F of negative x is equal to negative f of x. Now let's just look at two common mistakes. A lot of people want to say that the first one is even, but it's not, because it doesn't have symmetry over the y-axis. Even though the parabola itself can be folded in half, it can't be folded down the y-axis. So this is not even. And if you turn it upside down, it's a different photo. So this is not odd, in which case we say it is neither even nor odd. Now, the next one has the potential to be odd, because if you turn it upside down, it looks like a similar image, right? But if you closely examine the graph, the points are different. Like here, I am crossing through the coordinate 0, 1. But now my y-intercept is different when I turn it upside down. If you look at the top left of this graph, I'm way up here. But the top left of this graph, I'm closer towards the x-axis. So my point is, this is not odd, because when you turn it upside down, it's not laying in the same position as the original on the x-axis. It looks like it moved around, which means it does not have symmetry about the origin. And you can't fold this one in half either. They don't look the same. So this one has no symmetry going on. We say that this is neither even nor odd. So just be careful. You can't just look at the shape. You have to see where it lies on your xy axis to determine if it's an even function or an odd function.